Hi students. So in Unit 14, I asked you in the discussion board to end the video by stating one concept from the course that you're challenged by and provide a specific example of the type of problems from the textbook. And some of you did that, so I'm going to address those problems that students wanted me to explain. So there are only two. So alright, one problem was this is basically polynomial division. For this particular problem, there are two different ways you could simplify this. You could possibly factor this and cancel out the common factors. Also, you could perform long division, and you possibly could perform synthetic division. So there are really actually three ways you can actually do this problem. I'm going to go over polynomial division. So let's set up the problem as x plus 6 divided into x squared minus 11x minus 102. Always ensure that you have all of your terms, and we do. We start with x squared. 2 is our degree, is our highest exponent, and we have exponent 1, and we have our constant. We also have all of the terms we need in the denominator here, x plus 6. So even if the denominator was missing something, you would have to use a placeholder. But in this case, we don't have to use placeholders. So let's get started. First, x times what will give you x squared? So that's the first thing you do. X times what will give you x squared? Well, x. So I'm going to place the x over the like term. So this is x to the first power. I placed it over the term that was also x to the first power. Then, just like division from 4th, 5th grade, are you going to multiply x, this what you just put up here, times everything to your left here, which is called your divisor. So x times x plus 6. So basically this is what you're doing. You're doing a distributive property in your head. So what is x times x plus 6? X squared plus 6x. And then we always subtract. So basically that means change all the signs. So now x squared minus x squared cancels out. Negative 11x minus 6x is negative 17x, and we always bring down one term and we start over. X times what would just give you negative 17x. That's what we're concentrating on, the first terms. So again, x times what will give you negative 17x. Negative 17. So we'll put minus 17 here, and we're going to multiply that minus 17 times x plus 6 again. So again, we're distributing in our head. So when we distribute this, what do we get? We get negative 17x minus 102 again. And as always, we subtract or change the sign. So we have a 0 remainder. So the answer is x minus 17. Now, it turns out, just like regular division, this times this, if we multiply these two things together, we get x squared minus 11x minus 102. Alright, you could have also done this problem a different way. Alright, you could have used synthetic division. And you can use synthetic division when your divisor is of the form x minus k. So basically meaning the degree is 1 in the divisor. And since it was x plus 6, we can do synthetic division. So we will set it up as like this. K goes here. And in this case, since it's set up as minus k, since this is a plus, k must be negative, since a minus times a negative is positive. Then we'll take all of the coefficients of our dividend. We have 1, negative 11, and negative 102. Drop the first term, multiply negative 6 times 1, get negative 6. Add the column, get negative 17. Multiply negative 17 times negative 6, negative 102, positive 102. And again, we get 0. That 0 represents our remainder, or that last number represents our remainder. So our answer is here. Notice that our answer was x minus 17 before, and you see the similarities here. That 1 here represents the coefficient, and our constant here is that negative 17. So you write it as 1x minus 17. That first number is the coefficient of the first variable. So since we started with x squared, we always go down 1 because we are dividing by x to the first power. So our answer is x minus 17. So you can do synthetic division, long division, and you could have possibly factored x squared minus 11x minus 102 and cancel out with the x plus 6 as well. You will still have x minus 17. So 3 different ways to do that problem. Let's go to the next problem. So this problem, we're working with radicals, and of course, in order to add or subtract radicals, the radicals must have the same index and the same radicand. So meaning this number has to be the same. That's considered to be here, and we're all working with square roots for all of these, but these numbers also have to be the same, and they're not. But we have to simplify the radicals first to determine whether we can add or subtract these radicals. So we have 13. We're looking for a perfect square. That's in 28, which is 4. You got to get that out. So first have to figure out if we have perfect squares. We have 9 here. And of course, 7 can't be broken down. So we got to basically simplify this. Square root of 4 is 2. The square root of 9 is 3. And 4 radical 7 remains the same. 13 times 2 is 26. Radical 7 minus 6 radical 7 minus 4 radical 7. All of these now have the same index and radicand, so all my radicals are the same. So look at this as if they are all like terms, because let's just say this was I don't know, any variable, 26n minus 6n minus 4n. Since they all have the same radicals, identical radicals, we can simplify this. So 26 minus 6, that's 20 radical 7, minus 4 radical 7, so 20 minus 4, 16 radical 7. So the final answer is 16 radical 7. Alright, those were the only 2 specific problems that were suggested for this video, so I hope it helps those people who requested it. Alright, talk to you soon. Bye.